friends, and welcome back to the 16th day of this course. Today we are going to discuss something that we have already talked about in the previous two sessions. That means functions and pointers. So when we combine them, we get something called as pointers to functions. And yes, it is possible. Why? It's because functions also occupy some storage in the memory. For that reason, they also have a location and we can have access to its address using a pointer. In this way, we can access the address of any function. In front of you is the tiny snippet that tries to print the address where the main function is present. So let us go to the editor and see how it functions. Here we are, and this is the first program that we are going to see today. We can print the address of a function just by stating its name as it is, without the parenthesis, without any return type. No need to mention it. Just write the name of the function as we have written here, main. To specify the format of printing, we can use either %p or %x. Both works for pointers. In the last class, we have only seen %x. Now we will see how to use %p. There will not be much difference between them. So when we run it, we get the address or the location of this function is printed. Just the difference between %p and %x is that %p prints with a bit more precision. Like there are so many zeros before this number, and % just prints this number without so many zeros beforehand. Let us move to the second program. Here what we have done is we have tried to replicate the task done by a function. Our function is sum and it adds two numbers and returns the sum. What we are trying to do is we are trying to have a function pointer, and that will be used to call the function indirectly. So we will not write something like sum of a comma b. Instead, we will use the function pointer to call the function as it is. How we do so? First of all, we need to define the pointer to the function. For defining a pointer to the function, we have to be very careful. If the function has a return type integer, we have to mention integer return type for the pointer as well. The second thing, the parameters. If we take two parameters, we should have two parameters of the function pointer as well, and the parameters data type should also be exactly same as that of the function, otherwise it will not work. Once we have verified that the structure of the function and this pointer both are same, then we can implement the function using this pointer. Just write the pointer with a start, that means value of operator. After that, within the parenthesis, give the arguments. It can be called by value or it can be called by reference. Whatever you like, you can do that, and then you will get the result. Want to try this? So let us print it. We get, enter the values a and b, any two values, suppose 10 and -5. Then we get 5, right? Now we can get the same result if we just have used the sum function simply. So let us remove this line, give a semicolon here. Yes, now if we run it, we will get the same result. Suppose we give 10 and -5 again, we get 5 as the result. So it's working properly. This is how you can replicate any function using a function pointer. Isn't it cool enough? Let us switch back to the presentation. Yes, you see it right. We are going to swap two numbers in three different methods. This is good for practice because it involves the concepts of both functions as well as pointers that we have discussed in the last two classes. So let us have a look at it. We are trying to swap two numbers that user gives us in three different ways. The first way is defined in this function swap1, the second way is defined in this function swap2, and the third way is defined in this function swap3. Whichever function you want, you can call that function and pass the arguments by reference, not by value. Remember. Let us try with swap1. Suppose we give any two numbers 8 and 6, then we get the number that was given first has gone to the second number and vice versa. So we have successfully swapped them. Now how is it working? Let us go to the whiteboard. Our task is to swap two variables. Let us consider the variables as a container. This is variable x and this is variable y, and we are using a third container, that is a temporary one, so we write it temp, temp. Okay, now this is 5 and this is 6. If you want to swap this, then the final record state is 6 here and 5 there. What is the first step? The first step is to preserve any one of these values that is going to get overlapped or overwritten with the other value. If we have written x is equals to y in the second step, that means y's value will go to x and x original value will get lost. So to prevent this from happening, we are previously storing the value of x in a variable temp, temp, and this will keep the value 5 intact. So we are keeping 5 beforehand here. After that, when we write x is equals to y, this is step 2. So this was step 1 and this is step 2. In step 2 we are replacing the value 5 with that of 6. So now it does not contain 5, it contains 6. So we have 6 in x as well as 6 in y. So the swapping is 50% complete because y has been shifted to x but x has not been shifted to y. So to do the remaining 50% of this swapping, we write this third step. This is step 3. What we do in step 3? We transfer the content of temp to y. That means y gets the value of original x. So now 6 is going to be overwritten with the value 5. Now the swapping is 100% complete. So in short, the 3 steps that we do here is, first of all, we take a temporary variable to store any one of the values, suppose x. Then since x is going to be overwritten, we replace the value of x with that of y. And finally, we keep the value of original x into that of y. Just by writing these 3 lines, you can effectively swap any 2 variables that is given to you. Let us see the next method. In the second function, we haven't used any third variable to swap the 2 inputs. Seems strange, right? Again, we have 3 lines to swap these 2 variables. However, just by seeing them, it is difficult to understand what is happening. So let us go back to the whiteboard. The problem is same. We want to swap 2 variables. Let us represent them as containers x and y, and we do not have any third container this time. So suppose x is having a value 6 and y is having a value 5. The final desired state is x should have 5 and y should have 6. To reach from this state to this state, what we can do? We have first stored the sum of both the values, that means 6 plus 5 in x. Suppose x is equal to x plus y. This is the first step. Then what should be the second step now? We want to have 6 in y. To get 6 in y, what we can do is subtract 5 from this entire sum, right? If we subtract 5 from this entire sum, then these two gets cancelled and we are left with only 6, and that is what we want in y. So the second step, we write it as y is equal to the entire x minus y. That means 6 plus 5, this entire thing is x, minus y. What was y? Y was 5 initially. So we are subtracting 5 from this sum and finally we are getting y is equal to 6. So 50% of our swapping is already done. What is the last step? In the last step, we have x is equal to the entire sum 6 plus 5, and now y has the value 6. If we just subtract 6 from this sum, so this 2 will get cancelled and we will be left with 5. That is the required value, right? So the last step is written as x is equal to x minus y. That means 6 plus 5 minus 6. This will give you 5. And after these 3 steps, we have come to our goal state. That means x has become 5 and y has become 6. So the swapping is 100% complete. Congratulations. This method was a bit intuitive. It is difficult to make it out for the first time, as it happened with me as well. But after you see the 3 steps, you understand, wow, it works magically. Let us see the final method. In the third function as well, you can clearly see no third variable has been used. Still, we are swapping the 2 inputs. How is that possible? To understand these 3 lines of code, again let us go back to the whiteboard. To understand this third method, we need to have a good understanding of this bitwise XOR operation. We have seen this bitwise operation in operands and operators class. How this works? Suppose we have 2 variables a and b. They can take any values, any combination of values 0, 0, 0, 1, 1, 0 and 1, 1. These are the possible states that can happen between a and b. So if both are 0, then bitwise XOR, that means a XOR b, will give us 0. If both are 1, then also we get 0. That means if both the values are same, then we get 0. If they are different, that means in these two cases we get 1. This is how simple the working of bitwise XOR is. Okay. Now we don't go into deeper understanding of how XOR works actually. It has some combinations of the basic gates like A dot B, that means AND A and B, complement plus A complement and B. So this is the entire structure of XOR gate. But we are not going into the deeper understanding of how it works. We just want to know what are the values, what are the outcomes of XOR. Now, since we know how XOR works, we can understand the swapping process using a simple example. Again, we have the same problem. This is the container X or a variable X. This is a variable Y. Suppose X has the value 3 and Y has the value 4, and we want to swap them without using any third container or any third variable. The first step that we do is X is equal to X XOR Y. Now just keep on seeing what happens. We might not understand what is going on initially, but after the 3 steps we will understand how the entire thing got swapped. So when we write X is equals to X XOR Y, what we get? We effectively get the same result as X plus Y as we have done in the second method. Okay. How it happens? Let us see. So suppose we do 3 XOR 4. 3 XOR 4 is stored in X. Suppose. What is 3 XOR 4? For that we need to represent each of them in same number of bits. In 3 bits, 4 looks like this, 3 looks like this. Now calculate the XOR. So we are calculating XOR. This is the symbol of XOR, but this is not bitwise XOR. So the symbol of bitwise XOR is this caret symbol. 1 and 0, they are different, so 1, different, so 1, and different, so 1. So this gives us 7. This is the binary form of 7. Okay, this is actually 7 base 10, and this is actually 111 base 2 in binary. So as we have said that this works like addition. So if we do 3 XOR 4, we are getting 7. So we are storing X is equals to X plus Y. It is equivalent to that. What is the second step? Let me erase all these things. In the second step, we do Y is equal to X XOR Y. Okay. So now the X value is now no more 3. It is 7. When we do 7 XOR 4, what we get? 7 XOR 4, that means 111 XOR 100. If we do this, we get different, that means 1, different 1, same, that means 0. So this is nothing but the binary of 3. So 7 XOR 4 gives us 3. So Y is going to have the value 3. We replace 4 with 3. This is the same as we have done in the second method. In the second step, we have written Y is equal to X minus Y, right? We get 7 minus 4, that means 3. So we have a good resemblance between the second and the third methods, but here we are using only bitwise XOR operation. Coincidence? Not really. In the final step, what should we do? 50% swapping has already been done. Y has taken the value 3 that we have wanted. Now X should be taking the value 4. How to keep 4 in X? Current state of X is 7 and current state of Y is 3. It is simple. X is equal to X minus Y, right? The last step of the second method. How to do this in XOR? We write X is equal to X XOR Y. Let us check it. X is 7 and Y is 3. 7 XOR 3. That means 1 1 1, and we do XOR with 0 1 1. We get same means 0, same means 0, and different means 1. This gives us 4 because 100 is the binary equivalent of 4. And now we have correctly placed 4 in X and 3 in Y. So our swapping is 100% complete. You might think that this is a coincidence that the third method resembles each and every step with that of the second method. But there is no coincidence. The logic behind it is quite interesting. If you are fascinated about the bitwise operations, then you might know that suppose I add 3 and 4, I get 7, right? In binary it looks like this: 0 1 1, 1 0 0. If they are added, we get 1 1 1, that means 7. If I do XOR of any of these two numbers, I get the third number. So 3 XOR 4 will give me 7. Let us take any two other numbers. Suppose I take this pair 4 and 7, then 4 XOR 7 will give me 3, the third number. If I take this pair 3 and 7, then 3 XOR 7 will give me the other number 4. That means if I try to generalize this method, if there are three numbers A plus B giving C, then A's or B will give me C, A's or C will give me B, and B's or C will give me A. So this is a very interesting property that bitwise XOR follows. Using this property, I can just translate the second method in terms of bitwise XOR. That is what we have done in the third method in this program. You can try out any of these three methods. I have tried out the first method here by writing the name and calling by reference. Mind it is not call by value. If we run this and pass two numbers, suppose 4 and 9, we get 9 and 4. So perfectly they are swapped. Let us try any of these other functions, we will get the same result. Suppose swap 3, and now we try to run it. We get with 7 and 9, 9 and 7, right? Now, can we replace one of the functions using a function pointer? Can we represent it? Let us try. We have written a comment, and within that comment we have applied function pointer concept. Suppose we replace this line, we comment this line, and we activate this piece of code. Then what happens? We have defined a function pointer having the same return type as that of any of the swapping functions, right? Same return type. Then the parameters are also same. They are taking integer references, right? Finally, we have assigned the value of the first function swap1 to the pointer, and we have called the function using the pointer as we have seen in just the previous program. Let us see how this works. So we want to swap two numbers, suppose 11 and -6. We get -6 and 11. So it is working as well as the normal function calling. So you can either use pointers to call functions, or you can just call the functions in this way, whichever you prefer. That's all for today. I hope you loved this session as much as I do. Meet you in the next class with some more interesting stuff to do. Until then, stay well and have a nice day. Bye bye.